So this question here, we're asked to find if this U is a subspace of R, and U is defined to have the structure. It's 2R, negative S squared, and T for some RST in the real numbers. So that negative S squared is kind of a giveaway that this is not going to be a subspace. It's got a weird non-linear structure. So that usually means that there's going to be some kind of problems. But what we can do is just go through all the axioms and see where things are going to break down. Is 0 in U? Well, yes. If R and S and T are all 0, in that construction, we've got our 0 vector. So that axiom's fine. We're actually going to also find that this is closed under addition. So if we have, let's say, X and Y in U, does this imply that X plus Y is in U? Well, actually, yes, this is also going to be true. And it's a little bit harder to show, but it is in fact going to be true. So let's just say that X is going to be, I'll kind of call it 2R1, negative S1 squared, and T1. And Y is going to be 2R2, negative S2 squared, and T2. Then X plus Y is 2R1 plus 2R2, negative S1 squared minus S2 squared, and T1 plus T2. And now that negative S1 squared minus S2 squared might look like it's a problem, but it's actually really not. What we could actually do is write this in a really terrifying way. So this is 2 times R1 plus R2. So that's my R right there. And this is actually kind of an ugly thing. So it's the negative of the square root of S1 squared plus S2 squared squared. So yes, it's kind of written stupidly, but there's a reason why, and it's basically to tell me what that S is going to be. I can force it into that construction, and then T1 plus T2. So the R's are pretty natural, and the T's as well. So this is actually in U, and just kind of the construction that you would have here is my R is R1 plus R2. My T is natural, it's T1 plus T2. My S is kind of ugly, but it is this S1 squared plus S2 squared, and that thing's always defined because S1 squared plus S2 squared is non-negative. So this is in the right structure, it just isn't really very natural. So the one that's going to break down is actually the scalar multiple. So if X is in U, does this imply that CX is in U for all real C? And this is the one that's a problem. It's because that negative S squared is always negative. Well, not always, it could be 0, but it's never positive. And I could just take a C and make it be a negative, and it's going to flip the value of that second entry. So for example, if I choose R equals S equals T equals 1, then my X vector is going to be 2, negative 1, and 1. Then, and I'm also going to choose, let's say C is negative 1. Then CX is going to be negative 2, 1, and negative 1, but this is not in U, and that's because there's no S that's going to make this happen. So there's no S with negative S squared equals positive 1. That's impossible. So in fact, this is not in U. It is not closed under scalar multiplication, which is one of the requirements of a subspace. Therefore, it's not a subspace. I always spell that with a, always want to spell that with a P instead of a B. Subspace, subspace. So now for showing this, I didn't really need to do the first 2 steps, but I just want to show you that they do actually work. This is really all you need right here, is just showing that one of those three things breaks down, and it's the closure under scalar multiplication that does.